Water heaters are generally classified as continuous loads. This classification stems from their operational characteristics, where they consistently draw power to maintain a specific water temperature within their holding tank. The continuous nature of this power draw distinguishes them from intermittent loads, such as appliances that cycle on and off. In the context of electrical systems, a continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. This definition is crucial for proper circuit sizing and overcurrent protection, as outlined in the National Electrical Code, or NEC. The NEC mandates that conductors and overcurrent devices supplying continuous loads be rated for at least 125% of the continuous load current. This requirement is in place to prevent overheating and potential fire hazards due to prolonged high current draw. Electric water heaters typically incorporate a thermostat-controlled heating element immersed in the water tank. This element activates when the water temperature drops below a set point, drawing power to heat the water back to the desired temperature. Even when hot water is not actively being drawn from the tank, the heating element cycles on periodically to compensate for heat loss through the tank walls. This heat loss is inevitable, regardless of the insulation quality of the tank, resulting in a constant, albeit fluctuating, power demand. The power consumption of a water heater is influenced by several factors, including the tank size, the heating element wattage, the thermostat set point, the ambient temperature, and the frequency of hot water usage. Larger tanks and higher wattage elements will naturally consume more power, as will higher thermostat settings and lower ambient temperatures. The frequency of hot water usage has a direct impact on the duty cycle of the heating element. High demand scenarios, such as those found in restaurants, will result in the heating element operating for longer periods, leading to increased energy consumption. In restaurants, water heaters face particularly demanding operating conditions. The constant need for hot water in dishwashing, food preparation, and cleaning operations places a significant strain on the water heating system. The extended hours of operation coupled with the high volume of hot water usage often result in the water heater running continuously throughout the day. This continuous operation has implications for both energy costs and equipment lifespan. The increased energy consumption associated with continuous operation translates directly into higher utility bills. Additionally, the prolonged stress on the heating element and other components can accelerate wear and tear, potentially leading to premature failure. To mitigate these challenges, restaurants should carefully consider the sizing and efficiency of their water heating systems. Selecting a water heater with sufficient capacity to meet peak demand can prevent the system from being constantly overloaded. Investing in energy-efficient models with features such as improved insulation and advanced control systems can help reduce energy consumption. Regular maintenance, including flushing the tank to remove sediment buildup and inspecting the heating element for signs of corrosion, can extend the lifespan of the water heater. Furthermore, restaurants can implement water conservation measures to reduce the overall demand for hot water. Installing low-flow faucets and shower heads, repairing leaks promptly, and educating staff on water-saving practices can all contribute to significant reductions in water and energy consumption. In the context of electrical installations, it is crucial to accurately calculate the continuous load of a water heater to ensure proper circuit sizing and overcurrent protection. The NEC provides guidelines for calculating continuous loads, which must be followed to ensure compliance and safety. To determine the continuous load of a water heater, you first need to identify the nameplate rating of the heating element, which is typically expressed in watts. This rating indicates the maximum power that the heating element can draw when operating at its rated voltage. Once you have the wattage rating, you can calculate the current draw of the heating element using Ohm's law, which states that current equals power divided by voltage. For example, a 4,500 watt heating element operating at 240 volts will draw 18.75 amps. Since water heaters are considered continuous loads, the NEC requires that the conductors and overcurrent devices supplying the water heater be rated for at least 125% of the continuous load current. In the example above, 125% of 18.75 amps is 23.44 amps. Therefore, the conductors and overcurrent devices supplying the water heater must be rated for at least 23.44 amps. In practice, this typically means using a 30 amp circuit breaker and 10 American wire gauge, or AUG, copper conductors. It is important to consult the NEC for specific requirements and to ensure that all electrical work is performed by a qualified electrician. The NEC provides detailed tables and guidelines for conductor sizing, overcurrent protection, and other aspects of electrical installations. Failing to comply with the NEC can result in serious safety hazards, including electrical shock and fire. In addition to the NEC requirements, local building codes may also have specific requirements for water heater installations. It is important to check with your local building department to ensure that your installation complies with all applicable codes. In summary, water heaters are generally considered continuous loads due to their constant power draw to maintain water temperature. This classification has significant implications for electrical system design and installation, requiring compliance with NEC guidelines for circuit sizing and overcurrent protection. Restaurants, with their high hot water demands, must pay particular attention to the sizing, efficiency, and maintenance of their water heating systems to minimize energy consumption and extend equipment lifespan. By understanding the characteristics of continuous loads and following proper installation practices, you can ensure a safe and efficient water heating system. Firstly, understand the definition of a continuous load as defined by the National Electrical Code. Secondly, calculate the current draw of the water heater's heating element. Thirdly, apply the 125% factor to the calculated current. Fourthly, select conductors and overcurrent devices based on the adjusted current rating. Fifthly, consult the NEC for specific requirements and guidelines. Sixthly, check local building codes for any additional requirements. Seventhly, ensure that all electrical work is performed by a qualified electrician. Eighthly, consider the impact of continuous operation on energy costs and equipment lifespan. Ninthly, implement water conservation measures to reduce hot water demand. Tenthly, regularly maintain the water heater to ensure efficient operation and extend its lifespan. The proper sizing of the water heater is crucial for efficient operation and to avoid placing undue stress on the electrical system. A water heater that is too small will be constantly struggling to keep up with demand, leading to increased energy consumption and potential equipment failure. Conversely, a water heater that is too large will waste energy by heating water that is not needed. To determine the appropriate size water heater for a particular application, you need to consider the peak hot water demand. This is the maximum amount of hot water that is likely to be used at any given time. For restaurants, peak demand typically occurs during meal service, when multiple dishwashers, sinks, and other appliances are using hot water simultaneously. There are various methods for estimating peak hot water demand, including using industry guidelines, conducting a water usage audit, or consulting with a plumbing engineer. Once you have an estimate of peak demand, you can select a water heater with a capacity that is sufficient to meet that demand. In addition to capacity, you should also consider the recovery rate of the water heater. The recovery rate is the amount of hot water that the water heater can produce in a given amount of time, typically expressed in gallons per hour. A higher recovery rate means that the water heater can replenish its supply of hot water more quickly, which is important in high-demand applications. When selecting a water heater, you should also consider its energy efficiency. Energy-efficient water heaters can save you money on your utility bills and reduce your environmental impact. There are various types of energy-efficient water heaters available, including tankless water heaters, heat pump water heaters, and solar water heaters. Tankless water heaters heat water on demand, eliminating the need for a storage tank. This can save energy by reducing standby heat loss. Heat pump water heaters use electricity to transfer heat from the surrounding air to the water, making them more efficient than traditional electric water heaters. Solar water heaters use solar panels to heat water, providing a renewable energy source. In addition to selecting an energy-efficient water heater, you can also reduce your energy consumption by implementing water conservation measures. These measures can include installing low-flow faucets and shower heads, repairing leaks promptly, and educating staff on water-saving practices. By implementing these measures, you can significantly reduce your hot water demand and lower your utility bills. Regular maintenance is also essential for ensuring the efficient operation and extending the lifespan of your water heater. Maintenance tasks can include flushing the tank to remove sediment buildup, inspecting the heating element for signs of corrosion, and checking the thermostat for proper operation. By performing these maintenance tasks regularly, you can prevent problems from developing and keep your water heater running efficiently. In conclusion, water heaters are generally considered continuous loads, particularly in high-demand environments such as restaurants. Proper sizing, energy efficiency, water conservation, and regular maintenance are all crucial for ensuring the efficient and reliable operation of your water heating system. It is important to consult with qualified professionals to determine the best solution for your specific needs and to ensure compliance with all applicable codes and regulations. The considerations mentioned ensure a comprehensive approach to managing water heating systems as continuous loads, especially in demanding environments like restaurants.